This is an introduction to the eppd library for EnergyPlus. eppd is a Python library for programmatically using EnergyPlus. It utilizes pandas extensively, allowing us to use all of its features. These are some of the key functions used in the library. We will go over these with an example. The readIDF function loads the IDF file into an IDF-PD class. Changes are then applied to the model as needed. The writeIDF function is used to write the data back into the IDF file. The runBatch function executes all the EnergyPlus simulations in parallel. Finally, the getBatchXML function loads the XML outputs into an object. The output tables are accessed as pandas data frames. The library stores the IDF data as index pandas table. The index consists of the EnergyPlus object, the name, and the field number. Every field in the table can be accessed by passing these index values. Here's a quick view of the IDF data that was loaded earlier. The object, the name, and the field number is loaded as a multi-index. The field values are stored as data in the table. Fields are indexed numerically. We see that the zone multiplier is field number 6. The object and the field number is passed to the index. A colon representing the name retrieves the field from all the zones. This example demonstrates assigning the heating set point to a new value. EIDX is a helper class that provides constants for commonly used field numbers. It also helps with converting IP to SI units. In this example, we set the lighting power density to 0.82. Also, the unit conversion function is used to convert from IP to SI units. Code editors such as Jupyter Notebook and Visual Studio Code will provide autocomplete options that aid in the discovery of all available EIDX constants. Using pandas allows for vectorized operations to manipulate parameters. In this example, we use the assignment operator to increase the ventilation rate by 30%. There are two options to query object names. If a string or a list of strings is provided, an exact match is returned. If a tuple with rounded bracket is passed, each element is treated as a search string and the match names are returned. In this example, we see that the query returned all windows with the west and south in its name. The write_idf function writes the data back into the IDF file. Additional string objects to include in the IDF file can be passed in this function. The sObject class provides some standard IDF objects to add to the file. Items like EnergyPlus simulation settings, standard outputs can be retrieved using the sObject class. In this example, the model that was loaded earlier is saved as roffice.idf. While writing, the IDF statement to generate the ESO output file is appended using the sObject class. Note again that code editors can aid in the discovery of available sObject class items. The simulation cases to run are defined using a dictionary. The dictionary holds the IDF file and the weather file for each case. We can make changes to the model and easily add an additional run. The dictionary is then passed to the run batch function, which executes the simulations in parallel. For processing outputs, the library uses the XML file generated by EnergyPlus. All the outputs are returned as pandas data frame. The read XML function loads a single XML output file. This returns a XML_PD object that provides functions to access the different tables. In this example, calling the getUnmetZones function retrieves unmet zones greater than 100. The getBatchXML function is a utility function that loads all the XML files in the batch simulation. This helps to easily compare all the cases simulated in the batch. In summary, we see that the tool loads the IDF file into a pandas object, uses vectorized operations to change parameters, executes simulations in parallel, provides simulation outputs as pandas tables. This slide provides some additional notes to go over by pausing the video.